Hi everyone. So today we're going to work on what is called inverse relations and functions. So by the end of today, we're going to be able to find an inverse of the relation or a function. So let's first talk about inverse relations. So remember, a relation is a set of ordered pairs. Okay, and we can illustrate that by just a set of ordered pairs, a mapping, an equation, a graph, a table. Any of those represent a relation. Okay, so here is a relation. This is a mapping, and we have our domain, which is our x values, and our range, which is our y values. So think of it as an ordered pair, let's say A comma B. Then the inverse switches domain and range. Okay, so we go from A comma B to B comma A. So basically the x and y change places. So domain becomes range and range becomes the domain. Z over here. So notice the inverse, the domain was the range, is now the domain, and then domain is now the range. Now, not every relation is a function, and just like every inverse is you can have a relation whose inverse is a function, and you can have a function whose inverse is not a function, and you can have a function whose inverse is a function. So it could be functions both ways. Okay, so an inverse function is when the inverse and the relation, inverse and the original are both functions. Okay, so the inverse and, shall we say, the original are both functions. Okay. All right, so let's find some inverses. So let's start with an ordered pair. We'll start out with just looking at them. All right, so here is the ordered pair. Remember, the domain is x, the range is y. So basically the inverse, which we have a little notation for, that does not mean 1 over f of x. That says this is the inverse of a function who's called x, or f, called m for inverse. And we only do this if it's the inverse is a function. So we're going to see if we're going to keep using that. So these guys are all just going to switch places. There we go. All right, so the first one is 1 comma 1, then 5 comma 3, 7 comma 9, and 11 comma 13. There we go. That's all we're doing is switching x and y. Okay, so for ordered pairs, it's really easy. We literally physically move x and y and change the ordered pair. But if you're talking about an equation, there's a process. So like step A, step B, step C, boom, here's your answer kind of thing. So the first thing, and again, keep in mind that inverses, the kind of underlying theme here is that we're switching x and y, interchanging domain and range. So for the 4-step process, the first one, and we're going to do this by example, is make this y equals. Okay, so make the equation, or let's do it this way. Replace f of x with y. And the reason we want to do that is that if we're going to interchange x and y, we can't do that if it says f of x. So we're going to make this y equals the square root of 3x minus 2. There it is. Okay, second step. Switch x and y. Now, when I say switch an x and y, I literally mean switch the letters. So make this x equals the square root of 3y minus 2. That's it, like switch the letters, nothing else. Okay, our third step is solve for y. And this is where we might run into some trouble. Okay, so if I'm trying to get y by itself over here, first thing I'm going to do, I'm going to Square both sides. Okay, so we get x squared equals 3y minus 2. All right, so let's add 2. And then let's divide by 3. Okay. All right, so step 4 is replace y with f inverse of x if the inverse is a function. Okay, so how do we know that? We would probably want to graph it in our calculator. Okay, do I have my calculator? I do not have my calculator available to you. I am so sorry. So basically we would put x squared plus 2 all over 3 in my calculator and say, is it a function or not? Does it pass the vertical line test? And we discussed that the other day. All right, so this does pass the vertical line test. Take my word for it. So it would be f inverse of x is equal to x squared plus 2 all over 3. Because it's a quadratic, all quadratics are functions. So that's why we know it's a function. All right, so let's try a couple of this. We're going to do our 4-step process. So this is a line. All lines are functions, so that's why it has an f of x. So remember, our first step is to make this y equals. Switch the letters. Solve for y. And again, if you're not sure, we can always graph it in our calculator, but think of it this way. This is like 1/4 x, and then I can put the 8 over 4. Okay, so this is 1/4 x plus 2 is equal to y. That looks like y equals mx plus b to me. That's a line. So that is definitely an inverse. There we go. All right, let's try this one. All right, so everybody okay? Just make it y equals, switch x and y, solve for y, put in your calculator and graph it. That's the easiest way I can tell you to do it. See if it passes the vertical line test. Okay, and we're going to find there are certain shortcuts, like all lines are functions. All quadratics are functions. Okay, again, quadratics are x squareds. So let's make this y equals, switch x and y, solve for y. Okay, so remember, when we're physically taking a square root, we got that plus and minus thing happening. Okay, now I'm going to make a general statement here, and we're going to check it when we meet. X squared plus 2 underneath plus or minus is not a function. So y equals plus or minus the square root of x plus 2 is the inverse, but in this case the inverse is not a function. Okay, so so we're going to find out generalization, plus and minuses aren't functions. When you physically square root, you're going to get the plus and minus, which makes it not a function. Okay, so let's try this guy. Okay, switch your letters. Solve for y. Oops. All right, that's a function because it's y equals 2x. Y equals mx plus b. So that's a function. Okay. All right, we're going to try number 6 together because that looks a little complicated. So we're going to make it y equals. Oh, look at this. We're going to square root both sides. Oops, I forgot to switch my x and y. Wouldn't have been a function, or wouldn't have been an inverse. Okay, square root both sides. And again, plus or minus. So plus or minus the square root of x equals 3y minus 4. Okay, add the 4. Divide by 3. Okay, this is not a function because it's got the plus and minus. Okay, there we go. All right, now, so everybody okay with the 4-step process? Okay, now there are some things that we're going to notice about the graphs of the inverse and its original. Okay, so here's the graph of x squared minus 1. Okay, over 2. Okay, so there's the graph. Let's see if I can get it. That's pretty close. There we go. All right, so here's my graph. Now, the inverse, I'm going to do that in funky green color. Okay, so let's make it y equals x squared minus 1. X equals y squared minus 1. Add 1. Square root both sides. Okay, and we can see this on our calculators as well. So when I put in 0, I get positive and negative 1. Notice that it's not a function. Okay, there we go. All right, that's not too bad. All right, so we can see it does not pass the vertical line test. But I want you to notice that if I graph y equals x, which is, the line goes just like this, this, you should see that this is a mirror image along that line. So if we fold, like I had a piece of paper and folded it, it would like literally be on top of each other. So that's another way you can tell inverses. The graphs have to be mirror images along the lines y equals x. Okay? All right, so we're going to do one more thing, and that's involving our composition concept that we did the other day. Now, when you're trying to say, oh, I have this equation, this equation, are they inverses? The only way mathematically our evidence is to use composition. So we got to do f composed of g and g composed of f. We're going to do both. And both of these have to like simplify to x. Okay, if they don't both simplify to x, then they're not inverses of each other. Okay, so let's try it. So we're going to do f composed of g. Okay, so remember that means we're going to find g of x first. Now that's that guy. So x minus 1 over 2. And that means I'm going to take that and put it in to f. So 2 times x minus 1 over 2. Okay, so we're going to clean this up. We're going to simplify. Okay, I got these two are going to cancel. And we're going to, oops, I forgot the plus 1. Oof. So I got too involved in what I was doing. Oh, yay, it goes to x. Cha-cha, huzzah. All right, so that looks good. So let's go the other way. Okay, so we're going to start with f of x, which is 2x plus 1. Then I'm going to use g of 2x plus 1. So that means put that into g. So 2x plus 1 minus 1 all over 2. Okay, so that gives me, these guys are going to cancel, so that leaves 2x over 2, which is x. Huzzah! All right, there are some problems I left blank for you guys, like 2 and 4 and number 2 and prove the composition. Why don't you give us those a try? We'll check our answers and see how we did. So I'm going to start with this one. Okay, yes, these are inverses of each other. Okay, because they both equal x. All right, so let's try 2, 4. So here's 2. We squared both sides. I got x squared over 3. It's a quadratic. It's a function. Here, I'm going to solve. I got plus and minus the square root, not a function. All right. So let me know if you have any questions, guys. Please stay safe out there, and I'll talk to you again real soon.